Rise and shine, porcupines. It's Algebra with Al time, and I'm your host, Al Rossetti. Today we're looking at Algebra 2, Chapter 1, Unit 2, Properties of Real Numbers. Why don't we get started, shall we? Okay, so properties of real numbers. Remember, natural numbers. If I asked you to just start counting, where would you start? Everybody would just start with 1. So the term natural numbers, you should be able to remember that because you will start counting at 1. Whole numbers. Remember, what's a whole look like? Doesn't it look like the number 0? So you should be able to remember whole numbers because it starts with 0 to positive infinity. And then of course you need the negative numbers. Those are integers. And then irrational and rational. Well, let's go through this. Let's look at number 34. If you count from 0 to positive infinity, you're going to hit 34. If you count from 1 to positive infinity, you're going to hit 34. So it is natural, it is whole, it is an integer, it is real, and it is rational. Those are all the things that is. Okay, let's look at negative 525. It's not going to be natural because that starts at 1. It's not going to be whole, that starts at 0. But integer, it's going to be an integer, it's going to be rational, it's going to be real. 0.875. It's not going to be natural, whole, or an integer. They do not encompass fractions or decimals. It's going to be rational and it's going to be real. All right, 12 over 3. Well, to come up with this, we got to first solve it. 12 over 3 is 4. Positive 4, so you know it's natural, whole, integer, rational, and it's real. Number 5. Square root of 9. Negative 9. Negative square root 9. Once again, before we can come up with what that is, you got to simplify it. Square root of 9 is 3. The negative outside keeps it negative 3. That means it's going to be an integer. It's going to be rational. It's going to be real. Number 6. The square root of 30. Well, once again, use your calculators, simplify it. Obviously, it's going to be a positive number. So it's going to be natural, whole, it's going to be an integer, it's going to be real, and it's going to be rational. So here we go. Name of the properties. Okay, so number 7. Here's one thing you got to hold on to. If they change the order in which they arrange the values, it is commutative. Okay? If they change the order using parentheses and brackets, it is associative. So the first one, they actually change the order in which they put the terms, so that is commutative. The second one is distributive. You guys know that, 2 times r's. That's an easy one. I'm not going to even bother. You know that's the only one you guys learned from middle school, I think. All right. Whenever you see a 1 in the answer or in the problem, is multiplicative identity. So whenever you see the 1, that's the key. Multiplicative identity. All right, let's look at number 13. Do they change the order? They don't change the order. They change the order in which we would solve this with parentheses, but they do not change the order of the values. That is the associative property. Okay? So look at the difference between number 7 and 13. They change the order in 7, commutative. They change the order with brackets and parentheses, that's associative. Number 8. Whenever you see a 0, and that's the key, you see a 0 in it or an equal 0, that is additive identity. So multiplicative if you see a 1, additive if you see a 0. Look at number 10. Do they change the order in which they place the terms? They do not. It's 2r, 3r, 4r, then 2r, 3r, 4r. But they change the process with parentheses, so that's associative. Once again, you see a 1 there for 12. I don't even have to say it. You see the 1, you're going to say what? Multiplicative identity. That's right. 14. Here they do change the order. 10b in the first one, and then 12b is the first one on the other side. Commutative. That's how easy that is. That's how easy these properties can be explained to you. Look for the change in order. All right, so we're getting ready to move on. Okay, And so here's a little note, in case you didn't quite understand. I wrote this up there for you. So if order changes, it's commutative. If it doesn't change, it's associative. I know those are the two properties that you guys have trouble with, but it's all about placement of the terms. If you notice they've been moved, right away it's commutative. If you notice they're only putting parentheses and brackets in to change the way we do the order of operations, that's associative. If you see a 1 in the problem, if it's times 1 or equals 1, multiplicative identity. All right, find the additive inverse and multiplicative identity for each number. All right, so additive identity, it has to equal 0. So if you're starting out at 15, what's going to equal 0? Negative 15, right? So that's the additive identity. The multiplicative inverse, remember, multiplicative inverse has to equal 1. So what would you multiply 15 by to equal 1? How about 1 over 15? That's the inverse, right? 15 times 1 is 15. Divide by 15, you get 1. So for additive identity, what does it take to equal 0? Multiplicative identity, what do you got to do to equal 1? That's simple. All right, let's look at number 16, right? So 16, 1.25. Before we can do anything with the multiplicative inverse, we got to transform that into an improper fraction. We can do the additive identity real easy. So if you're at 1.25, what are you going to add to get to 0? Or subtract, right? You're going to subtract 1.25. So the additive identity is negative 1.25. Now the multiplicative inverse, we have to transform that into an improper fraction. You have to know how to do that. So if we have 1.25, you actually have 1 1/4, and you can transform that to an improper fraction by multiplying 4 times 1, right? And then add the 1 on top of the numerator, and you get 5 over 4. Now you know the inverse. The multiplicative inverse, for it to equal 1, if it's 5 over 4, the inverse is 4 over 5. And so the key here is being able to transform that decimal into a fraction, and then you just flip the fraction. That's the inverse, and that'll always equal 1. All right, number 17. This one's easy for us. Negative 4/5. What are we going to do to get to 0? Well, we're going to add 4/5. So that's some additive identity. It's already fraction form, so the inverse is 5 over 4. And notice it will always equal positive 1, not negative 1. So you're always going to bring the signs with it. Number 18. Look at 18, and can you transform that into an improper fraction? That's what you have to be able to do. Okay, 4 times 3 is 12, plus 3 is 15 over 4. Once you do that, then you just flip it upside down, you get 4 over 15. That's the multiplicative inverse. The additive inverse, boys and girls, I don't want to tell you, whatever the positive is, you write the exact same thing with the negative. If it's negative, you write the exact same thing with the positive. That's the only way you can get to 0, is if they're the exact same number and they're opposite signs. Okay, so I think you got a handle on that, don't you? It's too easy not to have a handle on that. All right, here we go. Simplify each expression. We all know how to combine like terms. Remember, like terms are the same variable, and if there's exponents involved, it has to match exactly. So x and x squared cannot be added together. So here we can add 3x and 2x together. 3 plus 2 is 5. Here we can add 5y minus 3y. You get 2y. Now what I would tell you to do is I would take those like terms and put them right underneath and add them straight up and down, just like you're used to in like 2nd and 3rd grades. That's how we learn how to add. Why not do it just like that? Why don't you do it the way that you're comfortable with? All right, number 20. Well, what do you see there? What are the like terms? Write them right underneath so you can see that we can add the x with the negative x, the negative y with the y, and the z with the z. Put them right underneath. And this, you're adding, go straight down vertical. And just remember, even though it's addition, you know that if they're opposite signs, we're actually subtracting. So don't let that mess with you there. All right, number 21. Now, what's important here? What's the key to this one? When you see the negative sign outside of the parenthesis, we all know there's a -1 there, and before we can combine like terms, we have to change the signs on everything in that parenthesis. So before you start adding these together, it's got to be -3g and -3h. That's something you just have to know by now. It's no one's ever going to tell you. It's not going to say change the signs. That I don't care if you're in algebra or calculus or trig. That is standard operation now. You just have to know how to do that. And once we do this, we combine the g's and the h's. And remember, look, so we have -3g and a +5g. Opposite signs, you have to subtract, keep the sign of the bigger number. So 2g minus 13h. All right, what we got? Simplify. Okay, so we have a squared minus a plus 4a minus 3a squared. Now here, exponents are involved. So what does that mean? You can only add together variables and exponents that are exactly the same. So if I remove that 3, I'm left with just an a squared. So I can add it to just another a squared, like an identical twin versus paternal. They have to be exact. So -3a squared, positive a squared, opposite signs we're going to subtract. You get -2a squared. Then we have minus a and 4a, once again, opposite signs. We're going to subtract, keep the sign a larger number, so you get +3a. And then there's nothing to combine with the 1 in the end, but you still have to include it in your answer. And there you go. All right, 23, what's special about this? Nothing really. Distribute to both terms, the 3 and the 5, and then combine them. So anytime we distribute, you know you're going to have to combine like terms. That's just standard. So 3m minus 3z plus 10m minus 5z. And you already know what your like terms are, the m's and the z's. So 3m and 10m. You can go 3 plus 10. I know you can. And then -3z and -5z. Same signs, add them together, keep the sign. You're going to get -8z. So really, this all comes down to fundamentals. You want to make sure that before you start the rest of this book, that you can do the fundamentals. Making sure you're good with your addition and subtraction of positive and negative integers. Making sure you can distribute. Making sure you know how to combine like terms. Making sure you know the order of operations. These are all the things they got to make sure before you move forward and be successful. And there you have it, 13m minus 8z. All right, we're getting ready to do one that has, and hopefully you picked up on it already, the minus sign in front of the parentheses. Here's what I think some of the problems that we have, as kids. We don't take a step back and look at the problem. We just start writing. But you need to take a step back and take a look at it and make sure you don't miss that minus sign and change the signs. Because combining like terms is just too easy to make that kind of mistake. But we change the signs on it, and then we already know what our like terms are. We combine them, and if you do the -1 correctly, all that happens is the signs change. That's it. Nothing happens to the numbers, nothing happens to the variables. The signs change, and we add them up. So you got -5x and 2x. Once again, opposite signs. You're going to have -3x. You've got -3y, +3y. Now here's where a lot of students will put 1 or put y. Just like 3 minus 3 is 0, 3y minus 3y is 0. Don't put anything. All right, 25. Nothing special about this. Distribute, combine like terms. 6 times 2w, 6 times v. Nothing fancy here. Now, and don't look at this as just, me going through these problems and you know, just copying stuff down, right? Nobody is taking the time to do every problem. I know when I was growing up, the teachers would say, hey, do 1 through 40 the odd, right? And I still have teachers like that today. But if you have a teacher that's going to give you all the problems, you're going to have them all here. You're not going to have just the odds. We're going to do every one of them for you and try to explain every one of them for you. So take this as an opportunity. All right, what do we have here? 12W plus 6V minus 8V minus 4W. 12 minus 4 and 6 minus 8. What are you going to get? I know you know this, so we're going to get 8W, right? And negative 2V. Opposite signs subtract. See, we don't have a problem with 12 minus 4, but what if I wrote negative 4 plus 12? Would you have a problem with that? You're subtracting because it's still opposite signs. Doesn't matter the order. All right, here comes a problem that every one of you would like to, I think most of us would just say, if I got all the other ones right, I'm just going to miss this one. I'm not going to do all that. But once again, this is just too easy for you to just blow by. Fractions are no big deal. Okay, so what's the math here? The math is 1 times 15 divided by 3. That's how you multiply a fraction. Or you can look at it, what is 1/3 of 15? Well, 1/3 of 15 is 5. That's the big picture. That's what we do in the real world. We don't sit there and find common denominators and all that. That's how you have to use fractions. But the math is 1 times 15 divided by 3. That's like 3rd or 4th grade. You guys can do that. 5D. Then it's 1 times 3 divided by 3. See how I'm writing it out? So if you don't like fractions and I show you 1 times 3 divided by 3, what are you going to say to me when you say it's too hard? When you say that's too hard, that's what I'm going to show you. All right, minus, here we go. The math again, 1 times 8 divided by 2. I'm telling you, that's all it is when it comes to fractions. So why we have this bigger version? Negative 1 times negative 10 divided by 2. And there you go. That's all it is. It's all multiplying a fraction by any whole. And if it doesn't simplify exactly, if there's a remainder, you just leave it in fraction form. If it was like 10 over 3 or whatever, you'd leave it 10 over 3. Okay, well, that's it today. I appreciate you being here. I hope this helps, and have a great day.